Hello everyone, good evening. Welcome back to the channel. Today we are going to continue our discussion on AWS, and just to have a brief recap, in the last session we discussed about traditional IT setup, wherein the idea I had, I decided to scale up slowly and steadily from my home to my society to an entire set of cities. And we saw different issues that I would encounter while we are going through this process. And in general, this was how the traditional IT setup looked like. A lot of companies, if you know, started from the homes, started from the garages. For one of the prime example would be Google. So this setup worked for a lot of time, but now we also see a lot of disadvantages that we have for this particular setup. And with the advancement in IT and technology, we can actually improve on the setup. So today's session, we are going to discuss about the advantages and disadvantages of this traditional IT setup. And we are going to move to the next session where we start to discuss about cloud. So before we do go on and understand what cloud solves and how it solves, we first need to understand what are the disadvantages of going ahead with this particular framework. So currently, the traditional IT setup presents the following set of advantages and disadvantages. Okay, let's quickly go over with the advantages that you control the entire infrastructure from physical access to virtual access of your resources. So for example, when I say I'm going to deploy my application and I'm going to deploy it in my laptop, it's entirely controlled with me. The entire control of the website as well as the deployment hardware software is completely controlled and managed and bought by me. Moreover, when I'm deploying it into my home network, which you can say a local area network, which will be my private Wi-Fi network, the network security, the home, the physical access to my laptop, everything is under my control. This is one of the best advantages or the best things about traditional IT setup, wherein if you have confidential data, it is kind of a worry to keep it on someone else's laptop or maybe someone else's server. And moreover, what if there's a team that is operating on your server wherein you have client data. An example would be bank software. So bank keep a lot of customer data. They also keep track of the account ID, bank balance, and so on and so forth. But they also need to store this data. You cannot store such sort of data on a laptop. You need huge servers, and moreover, those servers should be up and running all the time. But at the end of the day, when you're storing this data on some third party, not even third party, on your own servers, there will be a third party to the particular customer data that is going to operate it and manage it. Then it becomes your responsibility to physically as well as restrictively access those particular servers. So the access that you will be providing will be very restricted to very few members who will be maintaining the servers. Then there will be different sort of access wherein you're going to allow certain people, certain services to access your data. So everything is in your control, but again, that has its own risks. Now, the next point is at times large organizations often buy a lot of physical servers, compute capacity, and can afford to reuse the servers for different projects. For example, again going back to the same discussion that we had, we are a bank. We bought a lot of servers, and we are not going to be completely scaled out, right? Or maybe we are not going to completely scale in. There is definitely going to be a large amount of content that will always be available. Same goes for a college. So the number of seats in a college will be always determined at the start of a academic year, and it doesn't normally increase so rapidly. So, for example, if a college has for an IT, it has 100 seats, so there will be a capacity to you will provision the servers to have a capacity of 100 servers. Okay, and in instance, let's say you lose some of the seats or the number of students are less, you can still use those servers for other computing activities in your college. And there can be other simultaneous projects in other department where they want to leverage your compute power. It can still be reused, only given the condition where you have the capabilities, you are working in a mode where you can reuse some of the IT infrastructure that you have. Also, we often see a lot of companies hire or acquire an entirely small organization. So in such cases, they also get the IT assets that the new organization is bringing in, which will be advantageous to large organizations, and they can decide to reuse the existing hardware. Now, in such cases, the servers that you are buying will be a one-time upfront activity. Given the conditions of your server, the range and the age of the hardware, as well as the operating systems, as patching on all those things, the the servers may will most probably have a lot of lifetime in it, until unless if you see the Intel processors or the AMD processors with the 11 gen, 12 gen, 13 gen coming up every now and then, servers normally will have a lot of computing power, but they will also have a lot of memory in terms of storage capacity as well as in terms of internal RAM. So as long as you are provisioning your compute to a larger capacity, it will still be able to do a lot of tasks and do a lot of multitasking. And this can be a good thing to have, since you can also upscale your IT infrastructure by attaching external hard disks and memories. So if you are having a really updated hardware, it's not in such a huge capacity and you have multiple users of it, then this has always worked in IT infrastructure, and this will go on for a lot of time because you can anyway customize your server. Now, coming to the disadvantages. So when with the traditional IT setup, there is always a large upfront cost. So you can imagine that buying a laptop is so costly these days. How about buying an entire server which has maybe 5 TBs of RAM or 500 TBs of RAM and 5 TBs of 500 TBs of actual hard disk capacity? So those sort of servers are really huge, bulky, and costly. Moreover, getting the servers delivered from a vendor to your own location is will also be a costly affair. Secondly, when you want to really scale up fast and do it within a short span of time, provisioning and buying an entire set of server or servers is a time consuming task. Moreover, shipping them, getting them delivered to your location, configuring them, creating their own infrastructure and environment for the servers to house in will be a big challenge. Keeping the capabilities that it will need to serve, keeping the things in mind that it needs to serve a certain set of customers or users, and hence you need to really guess the capacity in advance. Suppose you buy a really high processing computer, but it's the CPU utilization is barely 20-30%. So you are guessing the capacity, and at times the capacity that we guess is either too high or either too low. Next, scale up and down of an environment needs to be planned diligently. Again, let's go back to the example where we have a college which has a certain set of seats, for example, 100 for an IT course of 4 years. Now, they are planning to upgrade the number of seats and they are getting the permission. So it will not be something that happens over a week or a month. It is a long due process that takes time. It takes necessary approvals, but this can also be simultaneously coupled with another activity wherein you can slowly and steadily plan to upgrade your infrastructure. But things can go very wrong very fast. In case if you are buying or provisioning the servers for a new need, but indeed you don't get that sort of a need, again that is an issue. Secondly, there are delivery timelines, operational timelines that you have to need take into consideration whenever you are planning this sort of an upgrade. Next is need to plan for operational costs such as rent for data center, power supply, and maintenance. So these are all operational costs wherein you are going to house your servers in your own location or maybe a rented place wherein you need a constant supply of electricity to the servers as well as a backup power in case the electricity goes out. Secondly, the servers do heat up a lot, so you need the controlled environment where you are keeping the server temperatures down. Then there will be regular updates to the hardware as well as the software that is present on those servers. And additionally, you need someone to monitor the application or the servers 24/7. So, discussing on the same topic, we have multiple issues as well. Whenever we are trying to replace the hardware on a particular server, we often have to take a downtime. So, you again have a critical condition where you are working on your actual servers, and there are other servers that are currently connected and are serving the client. So all sort of these things wherein your compute capacity is in your hand, but the capacity to scale up and down as well as the additional upfront cost, along with guessing the capacity of the IT infrastructure, are kind of bottlenecks of the traditional IT setup. In the next session, we will start with what is cloud computing, what is public cloud, what is AWS, and then we will also log in into the console, check, go through the CLI. There are multiple ways that you can access your AWS. We will go through all those ways. We will try to, experiment. We'll try to do changes. Additionally, I'm also AWS certified, so I'll be soon starting dedicated playlist or dedicated sessions for each and every certification that AWS provides. And we will go through the journey of becoming AWS certified as well. Okay, that's all for today's tutorial. I hope to see you in next time. Thank you.